Hey guys, so I'm going to show you how to break down numbers into just their prime factors. If you hear the term prime factors and you're like,
I'm lost.
then you should probably go back and watch a previous video. There's a few ways to do it, but I reckon factor trees are the easiest way to figure this stuff out, so I'm going to show you how to do them. As an example, we'll use 24. We're just going to break this number down into factors until you can't anymore, so you'll just be left with the prime factors, because that's what a prime number is, one that you can't divide down any further.
I knew that.
Okay, so we'll split 24 into 6 and 4. Then 6 will break down further into 3 and 2. And then 4 will break into 2 and 2. And that's what a factor tree looks like.
I'm Groot.
Pretty simple. Now you could have broken 24 down into 12 and 2 instead of 6 and 4. Choosing the factors with a smaller gap between them will make it quicker, but it doesn't matter because the end result will be the same. So unless your teacher tells you otherwise, do whichever one is most obvious to you. Let's do another example with a bigger number. So we'll take 120. Okay, so I look at that and straight away I see 12 and 10 as being the factors that are easiest to split it into.
You didn't see anything.
Then 12 I'll split into 6 and 2, 10 into 5 and 2. And the 6 I can split again into 3 and 2. So hopefully that's easy enough to see. Really, we're just breaking it down into factors until you can't break it down anymore. Okay, you can do this one. Draw me a factor tree for the number 60.
If it's so simple, why haven't you done it already?
Alright, there's plenty of ways to do this one. You could split it into 20 times 3 or 30 and 2, but I'll go with 6 and 10. From there, 6 would split into 2 and 3, and 10 into 5 and 2. All of which are prime factors, which tells you that we're done. So now you know how to make factor trees so that you can find the prime factors of numbers. But you might still have one question.
Like, what am I supposed to do with this? Like,
Well, there's a few things, but what your teacher will be asked to test you on is your ability to use this technique to be able to answer questions about greatest common divisors or factors when comparing two whole numbers.
Yeah, what's that about?
I know that sounds really technical, but I'll give you an example and hopefully it'll be a bit clearer. They might give you a question like this one. What is the greatest common factor of 26 and 14? Now, if they asked you this question, you wouldn't actually need to use the method that we just learned. You could figure it out just by writing out the factors of each of these numbers. So 26 has 1, 26, 2, and 13 as its factors, and 14 will have 1, 14, 2, and 7. So I've been asked what's the greatest common factor between the two? When you look at the list, hopefully it's clear that 1 and 2 are both common factors, and 2 is bigger than 1, so obviously 2 is the greatest common factor between these two numbers. So writing out all your factors and doing it that way wasn't that painful this time, but it can have issues.
Guy dresses up like a bat. Clearly has issues.
It's quite easy to miss factors using that method, particularly when the numbers start to get bigger. And once you're working with larger numbers, it's pretty time consuming for you to list out all the factors manually. But luckily now, we have factor trees to help us. If we were to do this same question but with the factor tree method, all you have to do is write out a factor tree for both numbers and then compare the roots of these trees, so the prime factors. You'd circle any roots that are similar. So in this case it's pretty simple because each number only has 2 in common. So the highest common factor, as we already figured out, is 2. I'll give you one last example that shows what happens when you have multiple prime factors in common. What's the greatest common factor of 30 and 105? Firstly, I hope you can see that trying to figure this out by listing the factors would be a real pain. 30 shouldn't be too difficult. I'd split it into 3 times 10, and then 10 is split into 5 and 2. However, 105 might stump you initially. But if you can see that it ends in 5, so it must be divisible by 5, that'll help. Dividing it by 5 will give you 21, which you can only divide one more time into 7 and 3. Now when we look at the roots, you can see that there's both a 3 and a 5 that these numbers have in common. So to find the greatest common factor, we would multiply these prime factors together. Since we have both 3 and 5 in common, that means the greatest common factor for 30 and 105 is going to be 15. One last thing to remember
One more thing!
is if there's nothing in common between the two trees, that doesn't mean their greatest common factor is 0. It means their greatest common factor is 1. Because every number has the common factor of 1.